All right, welcome back. It's Miss Clark again with some more school-wide learning videos. This week we're talking about trig. So some things that we're going to talk about: trigonometry, SOHCAHTOA, everyone's favorite thing, solving right triangles, graphing trig equations, and trigonometric identities, my pre-cal class's personal favorite. So here we go. First things first, SOHCAHTOA. You've been doing SOHCAHTOA since you were in geometry, which is super exciting, probably why this is part of the geometry school-wide learning section. So remember, sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and TOA, tangent, is equal to opposite over adjacent. I think it's personally a really good idea to go ahead and start by solving these problems by labeling the opposite side, the adjacent side, and the hypotenuse. Remember, adjacent means right next to the angle we're talking about, and opposite is across the triangle from the reference angle. So in solving right triangles, if you're given two sides and you're asked for the third side and it's a right triangle, always use the Pythagorean theorem. A squared plus b squared equals c squared. Lots of problems on the ACT will have that embedded in there somewhere where the Pythagorean theorem just makes your life a whole lot easier. So keep that in mind. Okay, in solving right triangles, so we're given a right triangle and I'm given an angle and one other side and I want to find a side. Remember, I'm going to set up equations such as this one, where I have 30 down here in the lower corner and 10 on the hypotenuse. I first need to figure out which trig function I'm using. I can tell because of my reference angle that I'm missing the opposite side in this triangle. So my equation is going to be sine of 30 equals x over 10. Because 30 is the angle I'm given, x is the opposite side, and I'm also given information about the hypotenuse. So I have info about the opposite and hypotenuse, which tells me I'm using sine. When I set up these equations, the best thing to do is cross multiply and multiply by the denominator of my ratio. And that'll help me solve for missing sides. One other thing the ACT likes to do is they like to give you a ratio of one trig function and ask for the other trig function. Always, always, always start by drawing the triangle and labeling whichever sides is given. If I'm given tangent of a certain angle equals 41 over 45, then I'm going to label the opposite side as 41 and the adjacent side as 45. Then use the Pythagorean theorem to find the hypotenuse. Now I know all three sides and I can find any trig ratio that it asked me for. Just something to keep in mind. Okay, next fun thing, trig graphs. The ACT loves to ask questions about trig graphs, specifically sine and cosine. So just some things to keep in mind is how high or what's the greatest value for either sine or cosine. If you're in an upper level math, you know that that's going to be 1. And the lowest value of sine or cosine is going to be -1. Now, transformations of trig graphs can sometimes change that, but it's really helpful to keep in mind that transformation of trig graphs work exactly the same as transformation of any other graphs. The number on the very outside by itself is going to move the graph up and down, depending upon whether it's positive or negative. I wouldn't get too caught up in the phase shifts and things until you reach that math class in high school. So, last but not least, the unit circle. I personally love the unit circle, but of course that's because I'm a nerdy math teacher. So just some things to keep in mind about the unit circle is that there's x and y coordinates all the way around. X coordinates relate to cosine and y coordinates relate to sine. And if I'm ever asked for a tangent value, I just need to do sine over cosine. And that will tell me the tangent of that specific angle. You'll also see the reciprocal identities down here, and then it goes even further into the Pythagorean identities using trig functions. So you'll see the top one, sine squared plus cosine squared equals 1, which is really helpful. So if I can remember that one, then I can always remember the other two. If I take the first trig function, sine squared plus cosine squared equals 1, and divide every single term by sine, it'll give me the next one, which is 1 plus cotangent squared equals cosecant squared. And then if I take the original function again and divide every single term by cosine, it'll give me tangent squared plus 1 equals secant squared. And those are the 3 Pythagorean identities with trig. They're really helpful in solving equations. I think that's all I have for trig and ACT prep questions. So if you ever need any extra help, just come by C104. I'll be glad to help you anytime. Thanks for having me.